to lesson number 2 on radicals. We're going to be working on adding and subtracting radicals. We're going to skip investigation 1 and 2 in this video, and we're just going to begin with the class examples. So with adding and subtracting radicals, it looks quite different than multiplying and dividing. In order to add and subtract radicals, the first thing we have to do is make sure that they are expressed as like radicals. And so what that means, if a radical is a like radical, that means it has to have the same radicand and the same index. All right, so if we think about what a radical looks like, it's made up of a radical sign, it's made up of an index, and it's made up of the radicand. Right, so the index and the radicand have to be similar, or well, they have to be the same. So write each expression in terms of a single radical. So we're going to be subtracting and adding these radicals. So the first thing we have to do is make sure that whatever is inside 80 and 20 is the same number. Now, in order to find the same number between these two values, we have to find a common number. So 80 and 20, they both end in 0, so the common number there would be 5. So 80, we could say, is square root of 16 times the square root of 5, minus 20, which is, well, if 5 goes in that 4 times, so square root of 4 times square root of 5. Now we see that we're going to be left with, well, 16 root 5 is 4 root 5 minus 2 root 5. From here, in order to subtract, we do the coefficient, which is the first number, and we minus the coefficients only. So that becomes 4 minus 2, which is 2, and then our square root 5, so whatever's in the radical sign stays the same. So this becomes 2 square root 5, which is equal to the square root of 80 minus the square root of 20. So we're going to do the exact same thing for this next question. I have the cube root of 80 plus the cube root of 270. This is going to become the cube root of 8 times the cube root of 10 plus, if I think about, well, both these are divisible by 0, so either 5 or 10 can come out of it. I have the cube root of 27 times cube root of 10. So I'm trying to get to radicals that are the same. So 10 and 10 is the same, and then 8 and 27 are both perfect cubes. So these examples, by the way, are just working out to be really nice like this. So that's going to be cube root of 8 is 2, cube root of 10 plus cube root of 27 is 3 times, that's cubed, cube root of 10. So again, we're going to be going our coefficients plus our coefficients, and then whatever the radicand is going to remain the same. So that becomes 5 times the cube root of 10. With my next example, we're still looking for common numbers. So 27, 75, 147. One trick is if you look at the smallest radicand that is here, 27 in this case, is think about numbers that go into 27. So what are some multiples of 27? Well, I know that 3 and 9 and 27 all go into 27. So if we think about 75, 9 does not go into 75 evenly, right? It's going to be 8.33. So the next best number to choose would be 3. So what we're going to be left with is 7 times, well, 27 is going to be square root of 9 times square root of 3 minus 3 times square root of 25 times square root of 3 plus 2 times, well, 147. Does 3 go into that? 49 times the square root of 49 times the square root of 3. Now we can simplify this. This becomes 7 times 3 root 3 minus 3 times 5 root 3 plus 2 times 7 root 3. And then we got to simplify this even more, and that would give us 21 root 3, 7 times 3, minus 3 times 5 is 15 root 3, plus 2 times 7, so 2 times 7 is 14 root 3. And finally, our coefficients plus our coefficients. And so everything that's a coefficient, I'm going to add together. So 21 minus 15 plus 14, that we're going to be left with 20. And remember, anything that's a radical, if it's the same radicand, is just going to remain as, well, in this case, square root 3. So for these next examples, and you're going to find with these questions that they do tend to take a little bit longer, and that's fine if it's taking a while. There's just, yeah, it usually ends up being less questions. But we're going to do the exact same thing that we did above. So we got to find bases, or not bases, we got to find radicands that are the same. So between 108, 8, 48, and 50, we got to find some similar bases. Now, it's okay if you can't find a base that's exactly the same between all of them. Usually you'll find, if there's 4 terms, you'll find 2 bases that are similar sometimes. So let's look at what we can break 108 into. So if I'm looking at 108 and 48, both of those are certainly divisible by 2, but what we're trying to see is what perfect square can I pull out of these numbers, all of these numbers? What perfect square can I pull out of them? So 108, if I divide by 2, I don't get a perfect square, I get 54. So that's not a perfect square, which means it's not what I want to use. So let's go up a little bit. 108, 30, so 108 divided by 3, I get 36. That is a perfect square. And since it's a perfect square, it's one that I can use in order to simplify this expression. So 5 root 36 times square root of 3 plus 3/4. Well, I know that 8 can be broken up into square root of 4 times square root of 2 minus 5/4. 48 I know is also divisible by 3, 16 times. So square root of 16 times 3 would be 16 times 3 is 48. Plus 1/2, and 3 will not go into 50 evenly, but 2 will, and it goes in 25 times, so 25 times 2. Next we're left with negative 5 times square root of 6, 36, sorry, is 6, root 3 plus 3/4 times square root of 4, which is 2, root 2, minus 5/4 times square root of 16 is 4, root 3, plus 1/2, square root of 25 is 5, root 2. And from here I can combine, well, I'm not going to combine them just yet. I do need to simplify a bit more. But after I've simplified as much as I can, then I can combine those like terms. And so negative 5 times 6 will be left with negative 30, root 3. 3/4 times 2, we're going to be left with 3/2 to the power of 2. Negative 5 over 4 times 4, we're going to end up with minus 5 to the power of 3. And 1/2 times 5, we're going to end up with 5 over 2 to the power of, or sorry, square root 2. Now I can combine my like terms. So the like terms I'm going to combine are these two and these two. So negative 30 minus 5, we're going to have negative 35 square root 3, and then 3/4 plus 5/2. Oh wait, this should not be 3/4. Sorry, this is a mistake. This should be 3/2. Yeah, that should be 3/2. So 3/2 plus 5/2 is going to be 8 over 2. 8 over 2 is 4. 4 root 2. And this is going to be our final answer. We can't actually simplify any more than this if we're looking for the exact value. All right, so next question, you actually approach the exact same way. So attempt this one at home, and it's exactly like what we did up here. The only difference is you're going to be dividing by 8, dividing by 3, and dividing by 2 at the very end. But your overall answer is not going to change. And another way you can look at it is if you just simplify some of them right away, and actually here, maybe I will do this one. So cube root of 64 over 8. Well, 64 over 8, well, cube root of 64 is just 4 over 8, so that this will simplify into 1 over 2. These next ones is where we're going to have to start simplifying. So 375. I know that 375 is divisible by 125, which is a perfect cube. And so I'm going to use that. So cube root of 125 times the cube root of 3 minus, I'm going to, instead of calling this 2 times cube root of 354 divided by 3, I'm just going to use that as 2/3, just to kind of make it a little easier. 54, if I'm looking for a perfect cube to go in here, I know that 27 goes in twice. So the cube root of 27 times cube root of 2 minus, over here now, I'm going to say that's 5/2. And another cube number that goes in 24 is 8. And so I'm going to use the cube root of 8 times the cube root of 3. And now we can simplify again, so that I'm going to be left with 1/2 plus 2 times 5 cube root 3 minus 2/3 times 3 times cube root of 2 minus 5 over 2 times 2 cube root 3. From here I can simplify, so it's going to be 1/2 plus 10 cube root 3 minus 2/3, so 6 is going to be 2 cube root 2 minus 5/2 times 2 is 10 divided by 2 is going to be 5 cube root 3, and I can combine my like terms. Like terms are going to be whatever is a square root or cube root 3, and I'm left with 1/2 plus 10 minus 5 is 5 cube root 3 minus 2 cube root 2, and this is my final answer. All right, next question. There we go. All right, we want to find the exact length of x. All right, so that's what we're looking for, and we want to find it as a decimal to the nearest tenth. So if I'm looking for this length, I know that this length plus this length would equal this length here. Another way I could look at this is that this length subtract this length has to equal this, right? Because these sides are going to be if I take this side and this side, they're going to add up to be this length. And so if I do that, then that will give you my value of x. So that means that x is going to equal 8 square root 2 plus 2 square root 12 minus 5 square root 27 subtract 4 square roots 18. Now when I get rid of these brackets, I need to distribute this negative sign into both of these values, making this negative and this positive. So getting rid of the brackets, I have 8 square root 2 plus 2 square root 12 minus 5 square root 27 plus 4 square root 18. X is then going to equal, well, I need to combine like terms here. So 8 square root 2 will not reduce anymore, but 2 square root 12 is going to reduce to 2 times square root of 4 times square root of 3 minus 5 square root 9 times square root 3 plus 4 times square root 9 times square root 2. And then we can simplify this even further. This is going to be 8 square root 2 plus 2 times 2 is going to be 4 square root 3 minus 5 times 3 is going to be 15 square root 3 plus 4 times 3 is going to be 12 square root 2. Now we can combine our like terms. So coefficients and coefficients, 8 and 12 is going to be 20 root 2. And I'll circle my like terms, or I'll highlight my like terms. So that's a like term, that's a like term. And then my two middle terms are like terms as well. So 8 and 12 is 20. 4 minus 15, we're going to be left with negative 11 root 3. Alright, so that's as an exact value. As a decimal to the nearest tenth, so this is going to be b. We got to find out what the decimal is to the nearest tenth. So part B is right here. Well, 20 times root 2 minus 11 times root 3. We get an answer of 9.2.